Yes, dear audience, very welcome from my side. I'm very happy to have a very special guest today and have the opportunity to make this interview. So it's Dr. Ilka, from my perspective, one of the most innovative companies and startups we have here in Germany. So I think I have several very interesting questions. So the first of all is that we are here on a digital fair. So there are a lot of people talking about digital twins. What is your interpretation? So I have the feeling that there are very different interpretations. So what is yours?
Yeah, I share your observation, Thomas. We call ourselves the digital twin company, and our interpretation, our understanding of a digital twin is, first of all, it's a virtual copy of something that already exists, or it could also be planned. And it could be as big as a whole city, for example, or it could scale all the way down to a machine or something smaller. And what we understand, what makes a difference is a digital twin should not just be a geometry or something, or showing something, or a nice looking visualization or rendering. That's not enough. What we really need inside the digital twin is a proper data structure, and that comes with objects. So it needs to be semantic, which means meaningful. And this is what we understand and what we create.
Okay, so my understanding is that you think that the digital twin is not just a 3D geometry, it's more like taking it alive so that it starts telling us something. And do you think that the future will be that we have definitely for most of our buildings the physical and the digital one?
Definitely, yes. And not just the buildings, it's everything. It's the whole built environment. It's the transport infrastructure, it's the energy infrastructure, it's power plants, it's whatever you mean by building, but it's all the assets that we operate and that we use as clients and as customers. Yeah, definitely.
Okay, then it would be very interesting to hear what is the special thing about your company. So you have a startup, and I know that you're working with AI as well, so a lot of fancy new things. So what is the special thing about LocLab?
Okay, our clients want to use their digital twins of their assets or their campuses or their portfolios for many, many different use cases to start with. That could be as simple as a visualization tool for a proper communication with residents, with stakeholders, showing people about what is the impact of something we have planned compared to the existing status. So that could be one really big use case. Other use cases are scenario planning, analysis, optimization of processes, fault finding, reporting, and all of that. So if you just imagine the variety of use cases that you could have, that means you need to have certain criteria or characteristics in your digital twin, especially when you create them. So our clients, they want their digital copies of their stuff to be cheap. They want it to be available quickly, ideally tomorrow. They wanted to have it in a small file size so that it runs on their standard hardware that they operate with. They want it to be fit for the purpose that they have in mind, as I just explained. And the most important thing is they want it to be semantic. And that is, when you think about that, that's a lot of things to deliver in one go. And this is where we have now developed a very low-cost method for producing these twins using games technology to meet all these criteria in one go.
Okay, that's very. I've seen some of the first solutions, and I think it's very impressive because it's more than we know from the standard 3D scans. So it's more getting it to a real object, yeah, to make it move and to work with it. So is this the special thing, that you have the opportunity not to end up with just a visualization, so to really create objects, to create plans, you really could work with afterwards?
Yeah. You said scans. Most other suppliers use laser scans to start with. In our view, laser scans are great for certain use cases or products, but they don't scale necessarily. So sometimes we copy entire cities or parts of a city. You can't laser scan the entire city. So and also laser scans are quite heavy in data load, and they're quite expensive. So we don't start with laser scans. We start with normal photographs. Or more recently, we have moved from photogrammetry to videogrammetry. We use action cameras, and that is super cheap. So just imagine a railway station the size of, we're in Munich, size of Munich or Hanover or Frankfurt, any city. The data capturing with our method, it only takes a few hours, not days and weeks. And the costs are definitely below 500 euros. And you can't meet that, you can't match that with a laser scan. So that's the starting point for just capturing data.
Okay.
And then in the processing then, so we've got our photographs, and then we have two things that are outstanding and that are the differentiator. One is we have a library of objects from the existing world, and that is the entire German rail equipment, that is road furniture, that's windows, and that library has been growing over 15 years because this is how long my business partner has been in that business. And also the second one, so this is one, and the second one is what we call our tool chain. This is a completely software or vendor independent assembly line of algorithms processing the data. And in the first step, we take the 2D data from photographs or videos, and we create the third dimension. We need a few reference measurements, otherwise the photos don't have a scale, and we create the third dimension using the principles of descriptive geometry and falling lines, vanishing points, and the algorithms are great in doing that. That's all math. They can do that, and they're brilliant in doing that.
Oh, that's definitely very impressive, I think, because it's turning around the process as we know it today, because it makes it so simple, so quick, so cheap, so easy, and afterwards you have a very powerful 3D model you can work with. So you said that then you place these objects inside, so there is an opportunity as well then to add other informations or further informations to it, or?
Yeah, so this is then probably, that's the most critical process then. So we then have the geometry and we still have textures and pixels in the scene. And then the algorithms do the object and pattern recognition. And that is where we also use artificial intelligence to train the algorithms to become better and better. And this is why we love to work with repeat clients, so we can train the algorithms on the object of the client. So for German Rail, we get an extremely high degree of automation now, because the algorithms are so well trained in finding the same mast again and the same signal again. And so the algorithms run through the scene, they find the objects in the or vectors or colors, etc., in the scene, in the pixels, and then they find a matching object in the library and they replace the pixels with the vector graphic. And that's the moment where the file size reduces, and we can deliver whole cities in a megabyte. We're not talking gigabyte, we're talking megabytes here. And also where the model becomes semantic. This is the absolute critical point.
Yeah, I think that is a very important point, I think, when we think about the mass of buildings we have out there, and when we want to turn it to digital twins, I think it would be it's very necessary that we really keep it handleable, and therefore I think small-sized models are definitely something which is very, very interesting. But I think there we could see a perfect example for these artificial intelligence solutions. Yeah, as I understood, it's a training process, and as soon as something is known to the system, then it could replace it immediately, and you have it just one time in the model, even if it occurs several times, because it's maybe an object which comes often.
Yeah. Okay. And this is where we then use principles that people do in design when they design in BIM now, and they use objects in the design process, and they use several instances of an object in design, and we do exactly the same, just coming from the other end of the telescope, and we meet somewhere in the middle. But in our models, you can always have, and we can even, from our modeling, from our tool chain, we can export into a 3D CAD environment, into a CAD format, and I will still keep the objects. So and that also, that is pretty outstanding. We can give people a proper 3D CAD model of an existing asset for a new design process, for a refurbishment or extension process, for example, and it will have objects. Okay. And these objects, because we have a generic data model, and because the objects come from our library, so they always have the same name and the same structure. So when our models get then connected to another data system, like an SAP or a Maximo, a facility management system, etc., we can map our data structure onto the target data structure. So everything that the client has and holds, all the data that clients hold in different systems, referring to certain objects, all of a sudden is connected to the visual representation of the same objects.
Very interesting. So my question would be, you already said that there are a lot of use cases out there you could address with your new organization, your company. So what are the most benefits you could see at the moment? You said it's more about process optimization, it's about facility management could work much more effective. So are these the most relevant two clients for you at the moment?
Follow the money, it will tell you. What do clients spend most of their money on when they operate and maintain and deliver the services?
Sure.
Exactly. And this is exactly where we go. We talk to our clients and say, so where does your money go? And one simple example, it sounds so simple, was that facilities management help desks gets a phone call and someone says, oh, I noticed there is some sort of a machine here and it's making funny noises. Okay. Where is this machine? What machine is it? Can you tell me? I don't know where I am. No, I don't know. I'm just realizing it makes funny noises. Happens every time. You wouldn't believe how many problems people have finding faults and reporting faults on site. So what we have is a 3D model, and everyone can have it on a screen, on an iPad. You can just click on something and you type in, this thing makes funny noises. And that gets sent to the facilities management team. They know exactly what it is. And then they can even remotely look at the problem. They can look at the sensor data, look at the live data that they receive. They can probably even reset it remotely. No one has to go out on site. Sure. And this is process optimization because it happens every time. So just one client who operates 135 hydropower plants. What it makes at the end of the year is amazing.
Okay. So I've seen that the examples and the solutions you create are as well animated. So it's a video, yeah. So you could as well show something like a mounting process. So as we have a lot of problems out there, getting the right quality on track. So might be that as well a use case that you could use your solutions and the opportunity to handle the objects as well to bring it out to on-site to show, for example, someone making the mounting work, how it need to be done, so how to put the separate things together. Yeah. So I saw just one of these solutions where you took something apart and put it back together. So this might be a very helpful thing for the people and the craftsmanship out there to enhance their quality when they have opportunities to see what they need to do. And not to need to be explained in another way.
Absolutely right, and that's another big use case for these digital twins is training. And it's not only that it improves the efficiency, etc., but improves safety as well. Just imagine that someone has to work on site in an unsecure environment, and you can train that in the secure environment, in the VR model, to the point where someone is really efficient and quick when he goes out on site and he knows exactly what he's doing, for example. Yes. Yeah.
So we also as well talked about one of your core features using artificial intelligence. So what is your impression? Is this really a game changer for the building industry in the upcoming years, or is it just something for very special things, or do you think it really spreads out in the upcoming years?
People are using the term artificial intelligence almost in so many different ways as they use digital twins. So I think there's two sides. One is what I would rather call rule-based calculations and algorithms, but even that is a massive leap forward if we had more rule-based algorithms doing certain things depending on rules. So for example, we can do rule-based design checks. When we work for Deutsche Bahn, so you can imagine a signal, there are lots of regulations where you can place a signal. So now you can tell, because the signal is an object in the scene, it is all semantic, it's meaningful, you can tell the signal where it is allowed to be placed and where not. So that helps the designer to place the signal. It also helps then the client at the end to check whether the designer has done a good job. So that is what I would call rule-based. And it's great, not really intelligent. The intelligent, I think, comes into the game when all of a sudden you give the algorithms, 10 different scenarios, and the algorithm comes up with the 11th one himself.
With an own idea, at least.
Yeah, so almost, yeah.
And so that might be the difference in between machine learning and artificial intelligence. But I think this is really something where we could see first really implementations because as well have fear about these topics because they don't know what's coming up. But I think with this example, we could see that it really makes sense. Yeah, it helps a lot. Otherwise, I think at least some of the business models won't work out when you could use the computer to do things which not need to be done by the people. Or
that's exactly our approach. We want to bring down the hurdles, make sure that your clients can use their standard hardware. You don't need terabytes of data. You can keep it a low file size and make it simple, make it intuitive, and bring the costs down. That's exactly our approach, and as it stands at the moment, it seems to work out.
Very good. So my last question would just be, what are the next steps? What are your visions? So you're already a very visionary organization, but I think it would be very interesting. What do you think are the next steps to come as well for your company?
I think some of that is what we are already starting to see here at the BIM World, where I saw lots of examples for data integration. And I think in construction we're a bit lagging behind when it comes to proper data integration. People talk a lot about data exchange and interoperability. I think we should be a bit more brave and a bit more visionary and talk about a proper integration, master data management, and have your different systems integrated by an open and scalable approach. And that's what I would love to see, and that's certainly something we're working on.
Thanks a lot, Dr. Ilka May. I think very impressive and a very forward-looking technology and organization. So to the audience, thanks a lot for watching. And I just could say, look up the webpage. It's LocLab.com or .de.
It's LocLab-consulting.com.
LocLab-consulting.com. So thanks a lot, Ilka May.
Thank you, Thomas.
Yeah.
Thank you.
See you.